Today's lesson is going to cover the effects of changing dimensions. So we're on page 12 to start. If the dimensions of a solid are multiplied by a scale factor of A, then two things can happen. The surface area, which I know we don't deal with, but just so you know in general, in case it comes up, is going to take the A value, the scale factor, and square it. It's going to be A squared times the original surface area. Then the volume is going to be A cubed times the original volume. Alright, so, number 5, it says, if the dimensions of a figure are multiplied by 4, so the scale factor that it's changing by is a scale factor of 4, how many times larger will the volume be? We take our scale factor, okay, and we cube it to see the volume change. So I need to take what I'm multiplying by 4, I need to cube it to see how much it's going to change. So it's going to be, well, 4 to the third is 64, and it says how many times larger, so it's going to be 64 times 4. If we look at number 7, the volume of a figure is 972 meters cubed. If the dimensions are multiplied by 2/3, so my scale factor is going to be 2/3, what will the volume of the new figure be? So again, I don't just multiply by A, my volume has to change by A to the third. So I need to take that 2/3 and I need to cube it. So in your calculator, you can do 2 ABC3 caret 3, and you should get 8 over 27. That's how much it's changing by. It wants to know my new volume, so it gave me my original volume. It was 972. So if I take that original volume and times it by how much it's changing by, I will get my new volume of 288 meters cubed. On number 8, solid A is similar to solid B. If the volume of solid A is 21 inches cubed, and the volume of solid B is 4,536 inches cubed, how many times smaller is solid A than solid B? Well, first I need to figure out how much they are different. I need to figure out what I multiply. So I need to figure out that A value of what I'm multiplying one by to get the other. So it's telling me that solid A is smaller than solid B. So I'm going to want to divide B by A. So I'm going to take 1,536 and divide it by that 21 to see what I did to 21 to make that 4,536. And when I do that, I get 216. So that's my A value. Sorry, my A to the third value. So if I want to find just what I did, I just want to find my A value, I need to get it along. So to get A to the third alone, I have to take something called the cube root. So when it's squared, we take the square root, and when it's to the third power, we take the cube root. And those will cancel out. So I'm left with A. And the cube root of 216 is actually 6. And it said it's getting smaller, 6 times smaller. Now, in your calculator, what we're going to do is we're going to push the second caret key. And if you notice above that, there's an X with your square root. So that's telling you that it's going to be whatever you tell it the X value is. So you want to type, clear it all out, and you want to type 3, second caret, and then 216. And you will get that 6 times 12. If you can't figure that out, we will work on question line. Alright, I want you to pause the video and try number 6 on your own. It says if the dimensions are doubled, so keep in mind what that would mean your A value is, but we don't use just the A value, we have to get all the way to the third value, and then it's asking you to find the volume of the new figure. Okay, let's turn to page 13. Changing only one dimension means that the figures are not going to be similar. So up to this point, when figures have been similar, they have changed both dimensions without necessarily being equal. Therefore, we need another strategy. In this situation, we choose test values. we calculate both the old and new surface area or volume, so that's volume, and then we compare our answers. So let's do this looking at number 10 instead. How many times larger is the volume of a square pyramid if the base edge is triple? So what's happening here is we are only going to be changing one of our dimensions instead of changing all. So I'm only changing my base edge. To start, I always do the same testing numbers. So my first test, I'm always going to set everything equal to 1 because that's the easiest number to work with. So let's first document what our formula is if I'm working with the volume of a square pyramid. Alright, so my volume formula is 1/3 big B times H. This is a square, so big B is side squared. So let's pick our two values based off of that. So my two dimensions that I'm using are side and height. So I'm going to set my side to 1, I'm going to set my height to 1. And I'm going to hypothetically run this off. My volume is equal to 1/3 big B, so side squared times H. Well, 1/3 times 1 squared is just 1/3, times 1 is just 1/3. So the volume here is just 1/3. On my second scenario, that is where I'm going to do my base edge triple. So on scenario 2, the item that's changing is my base edge, which could be my side or my height. So my side is getting tripled. Well, if my side was 1, tripling it, 1 times 3 is going to be 3. And my height stays the same, didn't tell me my height changed. So now I'm going to run the volume, where I take 1/3 side squared, b squared, times my height, 1. I'm going to figure out what that is. Well, this is 1/3 times 3 squared is 9, and times by 1 doesn't change it. 1/3 times 9 is going to give me a volume of 3. So I need to see how much these are changing. I'm going to take my new volume, the volume that I altered, so the one that I tripled, and I'm going to divide it by my start volume. So I'm going to take volume 2 divided by volume 1. And my volume of my second test was 3, divided by my volume of the first test was 1/3. And that's going to give me 9 times larger. And what that actually is going back to, if you think about it, is it's going back to the fact that that 3 was squared. So my 9 is sitting right there. Alright, let's look at number 13. How many times larger is the volume of a cone if the radius is multiplied by 6? So what I'm changing is that radius. Well, my volume of my cone formula is 1/3 I radius squared times height. So my two dimensions that I need to document are my radius and my height. Again, for my first test, I always have both equal to 1. Alright, running that formula, volume is equal to 1/3 I radius of 1 squared equals 1. 1 squared is 1, 1 is 1. So I'm really just doing 1/3 times pi, which can be left like that, or we could write it as pi over 3. And you can figure out that decimal if you want. I like to just leave it in terms of pi, less work on our end, but if we wanted to do pi divided by 3, we would get 1.05. Rounding is just going to throw us off. Alright, and then the next scenario, I want to multiply my radius by 6. So if my radius was 1, it's now going to be 1 times 6 is 6, and my height doesn't change. So volume is 1/3 I radius, which is 6 squared times height. So this is 1/3 I, 6 squared is 36, and times it by 1 is 10. So I'm really taking 1/3 times 36, which is going to give us 12. Oops, that's pausing. 12 pi, which again, if you wanted to find the decimal version of that, 12 pi is 37.7. Remember, I'm trying to figure out how many times larger it is, so I'm going to take my volume 2 divided by my volume 1. So volume 2 is 12 pi, dividing it by pi over 3. Or if you want to use those decimals, you could do 37.7 divided by 1.05. And regardless of what you do, you're going to get 36 times 100. Again, we can find that in our problem. You can see it right here. 36 because then radius that squared. So go ahead and try number 9 on your own and answer it when you are asked. Just be careful what your A value is. The height is being doubled. And then everything else should be straightforward from there. Alright, if you have any questions, please bring them to class tomorrow. Have a great rest of your day.